All right, good afternoon. We're going to do a video on chemical formulas and nomenclature. We've already talked about bonding and Lewis diagrams and valence electrons and all those kinds of things. Now we're just going to look at what it means, what a chemical formula is, and how we get the name of that formula. So a couple of definitions before we start. A compound. You need to know that a compound occurs when elements of different atoms of elements are joined together. The way we represent those compounds is with a chemical formula. And a formula contains the number of atoms of each element. So for example, H2O means that I have 2 hydrogens and 1 oxygen. CH4 means I have 4 hydrogens and 1 carbon. C6H12O6, which is sugar, means that I have 6 carbons, 12 hydrogens, and 6 oxygens. There are 3 different types of chemical formulas. We have what's known as the empirical formula, which is just the simple whole number ratio. Okay, if we think back to math class, if I have 2 to 4, that's a ratio. The simplest whole number ratio would be if I reduce that down to 1/2. So in the case of sugar, C6H12O6, I have a ratio of 6 to 12 to 6. I can reduce that ratio down because 6 will go into 6 one time, 6 will go into 12 2 times, and 6 will go into 6 one time. So this is the simplest whole number ratio. So our empirical formula would be CH2O. A molecular formula tells exactly how many atoms are actually present. So for sugar, C6H12O6, that is our molecular formula. It tells me exactly how many atoms are present there in that molecule. A structural formula shows me how they are bonded together. That was kind of like the marshmallow models that we built in class a couple of days back when we said they were trigonal, planar, or tetrahedral, or we looked at how they were shaped. That's a structural formula. Okay, how do we name compounds? Formula names are derived from the type of compound it is, whether it's ionic or covalent, and there are sets of rules for each one. For ionic compounds, you always have the empirical formula. You always write down the simplest whole number ratio, and then you put "ide" at the ending of the molecule. All ionic compounds have a metal and a nonmetal. They're all called salts. So we name the first. Okay. So we name the first element. Then we name the second element and put IDE at the end of that second element. So NaCl is sodium chloride. MgBr is magnesium bromide. Okay. Let's scroll down and look at rule number 2. Rule number 2 deals with those elements that can have more than one charge. Always, before today, we've said that the number of valence electrons depends on what column of the periodic table it is, and that determines its charge. Well, there are some elements that, especially those in the middle, I said we couldn't use that rule for those elements in the middle. So they have their own special rules for how you name them. And I think we are just going to, you can read through that if you want to. But we may come back to that later. I think for right now we're going to skip over that. All right, let's talk about covalent compounds. Let's talk about covalent compounds. Covalents, remember, are where you have two nonmetals. You have two nonmetals. I spelled metals wrong. Now, to show how many of each element you have, we use some prefixes. These prefixes right here are the ones we use to show how many elements or atoms are in that particular formula. We do not do that with ionic compounds because there's only one way to form ionic compounds. So there's no need to put prefixes. You can't form sodium chloride any other way except with one sodium and one chlorine. It just won't happen. But with covalents, you can have several different compounds made of the same elements, like carbon dioxide and carbon monoxide. They're both carbon and oxygen. So we have to find some way to distinguish between the two. We do that using prefixes. Mono means 1, di is 2, tri is 3, tetra is 4, pent is 5, hept is 6, hex is 7, and it goes on up. So the rule is the second element, again, always ends in IDE, and then you put the prefixes in front of elements that you have more than one of. So N2O3 would be di-nitrogen, because I have two of them, tri-oxide, because I have 3 oxygens, and then the ending is always IDE. If there are two conflicting vowels next to each other, one of them is usually dropped. So carbon monoxide. There's one carbon, so I don't put the mono in front, but one carbon. Mono means 1, but rather than saying monoxide, we just drop off one of the O's and say monoxide. Okay. Polyatomic ions. Polyatomic ions, you can remember using the following mnemonic. NASKT, NASKIP, I guess that's how they pronounce it, pronounced NASKIP. So nitrogen, acetate, sulfate, carbonate, phosphate. What you do is you just name the element that they're attached to and then put the name of the polyatomic ion at the end. Okay. Looks like that's it. Let's go back to these other, to rule number 2 on the ionic compounds. When there's more than one oxidation number, use the stock system. You put a Roman numeral to indicate the charge. Alternatively, you can use the oxidation state or the us and the ick. The first oxidation state ends in us, the second in ick. Actually, I think we are just going to skip through that. We may come back to a few examples and just work examples that way. Okay. I'm going to start working some examples and naming some compounds. Okay. Let's do some ionics first. LiF. It's an ionic compound. What we're going to do is you name the first element first, lithium, and then you name the second element, but you put IDE on the end. So rather than being fluorine, I take off the ene and put on IDE, and it's fluoride. Lithium fluoride. Okay. MgCl2. Again, it's an ionic compound, so we got to follow the rules for ionic compounds, which would be magnesium, chloride. Instead of chlorine, we would say chloride. This is another ionic compound. is going to be calcium, because Ca is calcium. Oxygen turns into oxide. Calcium oxide. We name the first element first, that's sodium. Second element, and change the ending to IDE. So instead of bromine, it would be bromide. Let's look at SrCl. That is strontium, chloride. Change the chlorine to ide. Let's look at one with a okay, so I'm going to name the first element first. That's magnesium. The second element, so remember that's a positive 2, that's a negative 2. They're metal, non-metal, positive, negative. And the second element is carbonate. That's a polyatomic ion, carbonate. So we would call this magnesium carbonate. If it's a polyatomic ion, you don't put the IDE on the end of it because that is the name of that ion, carbonate. So you don't need to change the ending if it's a polyatomic ion. So let's try another one that way. Let's try sodium NaOH. That's a polyatomic ion, one of the ones you had to memorize. So this would be called sodium, and then the name of that polyatomic ion, hydroxide. Okay. Okay, let's look at practicing. So I'm going to do a very easy one first. Carbon. So we name the first element first, and we don't have to, if there's only one of the first element, we do not need to put mono in the front. We don't ever do that. If it's more than one, then we would put a prefix. But one on the front element, we don't put the prefix. And then we look at how many of the second element I have. I have 2, so the prefix for 2 is di. This is oxygen, so oxygen changes to oxide. And we have carbon, dioxide. CO would be carbon, and there's only one oxygen there because there's no subscript, so that means there's just one of them. It's understood to be one. So this is carbon monoxide. If we look at this one, this would be di-nitrogen because there are 2 nitrogens. Pent, because there are 5, oxide, 5 oxygens. That's all there is to naming the covalent compounds. They're pretty easy. Okay. Salts made with other metals or polyatomic, other ionic compounds like lead, chloride, those are a little more difficult to do the names. I think I'm going to leave those for your chemistry class. I think we will not do any of the transition metal salts, and lead's a transition metal. Okay, so hope this is helpful. Hope you have a great afternoon, and we will see you tomorrow in class.